Okay, let's start with a tension that I think everyone feels right now, but maybe doesn't quite know how to articulate.
Mm,
On one hand, you open your news feed or you doom scroll through X, and it is all existential risk.
right. All the time.
It's Terminator scenarios, super intelligence, the idea that AI is this runaway train that might eventually derail humanity.
Hmm.
It's a very dramatic, very Hollywood-style narrative of man versus machine.
Exactly. It's the narrative of fear, the high-stakes sci-fi drama where the robots take over, and it sucks all the air out of the room.
It really does. But then you put down the phone and you look at the mundane reality of what we actually need AI to do. You look
Yeah.
at the problems we need to solve today, and that sci-fi narrative feels, I don't know, disconnected.
Completely. It feels like a completely different universe.
And that is where we are starting today. We are looking at a stack of sources that argue something pretty radical, that the only rational starting point for global AI cooperation, the only way to stop that man versus machine war before it even starts, isn't weapons treaties.
Yeah.
It isn't financial regulation.
Not even close.
It's global education.
It's a fascinating pivot, isn't it? Because when we talk about AI safety, our minds immediately go to, kill switches or alignment or these air-gapped servers in a mountain somewhere.
Right, the technical fixes.
The technical fixes.
Yeah.
But the sources we're diving into today suggest that the real safety mechanism, it's a classroom. Or, more specifically, the lack of one.
Right. And just to set the stakes here, because they are massive, we are not talking about, upgrading the smart boards in a suburban high school. That's not the scale.
No, this is a whole different level.
We're talking about 260 million children who are currently out of school entirely.
Just not in the system at all.
Not in the system. And then hundreds of millions more who are in school but effectively aren't learning because the systems are just so broken, the teachers are overwhelmed, there are no resources.
They're being warehoused, not educated.
Exactly. And the thesis here is, if we can solve that problem, if we can figure out how to teach a kid in a village with no electricity and no trained teacher, then we actually solve the coordination problems that threaten the whole world.
It's what one of the sources calls the rehearsal space theory.
I love that phrase.
It's perfect. If we can't cooperate on teaching a child to read, which is something literally nobody on the planet opposes, then we have zero chance, absolutely zero chance of cooperating on nuclear-level AI safety down the road.
It's the warm-up act for saving the world.
It is. You build the muscles first.
So today isn't just about EdTech in the way we usually think about it. We are going way, way deeper. We're talking about sovereign AI, we're talking about freemium models for the entire planet, and we're talking about escaping what's called pilot purgatory.
Oh, that's a painful one. We'll definitely get into that.
And we're going to unpack a three-part solution, a trifecta, as the sources call it, that involve conversational AI in 100 languages, free satellite internet, and a device that costs $10.
Which, when you first hear it, it sounds impossible. It sounds like pure fantasy.
It does.
But then you look at the economics, you look at the underlying technology trends, and you start to realize it might be the only way forward that actually makes sense.
Exactly. So let's dive in. Section 1, the arena where everyone wins. Why education? Why is this the hill to die on for AI cooperation?
To really get this, you have to look at what the sources call the coordination problem. This is classic game theory.
Okay.
Right now, all the major AI labs and all the major nations are in a race. It's a high-stakes, zero-sum game.
What does zero-sum mean in this context?
It means my win is your loss. If I slow down my AI development to be extra safe and you speed up, you beat me, you get the economic dominance, you get the military edge. So the rational choice for everyone is to just keep running as fast as possible, even if we all know we're running towards a cliff.
Right, because the first one to blink loses.
Precisely. We can't coordinate on military AI because it's all top secret. We can't coordinate on financial AI because it's all about grabbing power and market share.
Everyone is hiding their cards. It's a high-stakes poker game where everyone has a gun under the table.
That's the perfect analogy. But education. Education is different. It's what game theorists call positive sum.
Meaning my win can also be your win.
Exactly. If I develop an AI that teaches algebra really, really well in Hindi, and I share the basic principles of that with you, I don't lose anything.
Right.
I haven't given you a weapon. I haven't given you a critical trade secret that's going to bankrupt my company. In fact, if the whole world gets smarter and more educated, my economy actually does better in the long run because there are more people to trade with, more scientists to collaborate with.
It raises the tide for all boats.
It does. And beyond the economics, it's morally unimpeachable. You will never find a dictator, a democracy, a CEO, anyone who goes on record saying, you know what, I hate literacy. Let's have less of that.
It's the ultimate neutral ground in Switzerland.
It is. It's the one arena where everyone can come to the table without feeling like they're about to get their pocket picked. And the argument in these sources is that we need to use this neutral ground as a rehearsal space.
The rehearsal space again.
Yes. We need to build the muscles of restraint, the muscles of trust. If Google, OpenAI, Anthropic, and, the big Chinese labs can all agree on a shared safety protocol for teaching physics to third graders,
Something low stakes.
incredibly low stakes. If they can share data on that, if they can build a common framework, they establish a line of communication. They build a tiny, tiny kernel of trust.
So that later, when they need to discuss something genuinely terrifying, like a rogue autonomous weapon system or a recursive, self-improving AI that's gone off the rails, they aren't strangers.
They're not starting from zero. They have a channel. They have a precedent for cooperation. They've practiced.
That is such a powerful idea.
Yeah.
You don't try to draft a global peace treaty in the middle of World War III. You practice peace beforehand on something small.
You practice on the small stuff so you're ready for the big stuff.
But here's the thing, and the sources are very, very clear on this. We have a window of opportunity, and it's closing.
Yes. This is the urgency in all of this. Right now, AI is powerful enough to be genuinely useful. It can translate, it can explain complex topics, it can reason in basic ways.
And it do the job.
It can do the job. But it isn't so powerful and so scary yet that nations have completely locked it down behind national firewalls. We are in this brief, fragile moment where we can still deploy it globally.
So the fear hasn't completely taken over yet.
Exactly. But if we wait 5 years, 10 years, the geopolitical walls might be too high. The splinternet, this idea of a fractured, balkanized internet, might be absolute. China will have its AI, the US will have its AI, Europe will have its, and they won't talk to each other.
And the chance to build that shared rehearsal space is gone.
It's gone. The window is shut.
So we have to move now.
What?
Which, of course, means confronting reality. And this is where the sources get really, really gritty. We move into section 2. Reality versus the demo. And I love this phrase from one of the texts, the transition from the demo to the dirt road.
It's the classic Silicon Valley trap, isn't it? It's so vivid. You have this polished demo in a beautiful, air-conditioned conference room in San Francisco.
Perfect lighting, perfect sound.
The internet is fiber optic. The devices are all the latest $1,000 iPhones. The electricity is constant. The demo works flawlessly. Everyone claps.
VCs write a check.
Exactly. Then you take that same app, that same piece of software, to a rural school in the global south, or frankly, even a rural part of Appalachia in the US, and it breaks. It completely falls apart.
The sources list what they call 12 pain points, but let's hit the really big ones. The first one is what they call the floor problem, which is basically infrastructure.
Yeah, the infrastructure fallacy is assuming a solid floor to build on. It's assuming always on internet.
Which is just not the reality.
It's not the reality for billions of people. You're dealing with intermittent power, maybe a few hours a day if you're lucky. You're dealing with 2G connections that drop in and out. And here is where it gets a little technical, but it's absolutely crucial. Latency.
The lag. The delay.
The lag. In that San Francisco demo, a 30-second pause while the AI thinks is a glitch. You apologize, you refresh the page. In a real conversation with the child, a 30-second pause breaks the illusion completely.
It shatters the magic.
Utterly. If a kid asks, why is the sky blue? And the AI hangs for nearly a minute because the signal is struggling to bounce off a distant tower and back, the kid disengages.
They don't think, oh, bad network. They think this thing is dumb.
This is a dumb robot. The trust is gone. The conversational flow, the magic of feeling like you're talking to something intelligent. It requires speed, sub-second responses, anything more. And it's just a frustratingly slow search engine.
And it's not just the internet, is it? It's the device itself. I think we, in the developed world, have this assumption that everyone has a personal smartphone. But the sources talk about the shared phone problem.
This is a huge, huge barrier that so many tech companies just don't see. In a typical household in, say, a village in rural India, there might be one smartphone. One.
And it has an owner.
It belongs to the father. He's the one who paid for it. He takes it with him when he goes to work in the fields or to the city. He comes back at night. Maybe the mother gets to use it to watch a video. Then maybe the oldest son gets it for a bit.
And the daughter.
The daughter, who, by all the data, often needs the educational access the most, she might get 5 minutes at the very end of the day if she's lucky.
So if you design an app that assumes one user, one device, with a persistent login and personal notifications.
It's fundamentally broken for that context. It just doesn't work. If your app requires two-factor authentication via SMS and assumes the user today is the same person as the user yesterday, it's useless. You have to design for asynchronous, multi-user, shared access. It's a completely different paradigm.
Which is a much harder engineering problem to solve.
Much harder, and it leads right into pain point 2, the English trap.
Oh, this one really stood out to me. We see these incredible translation demos from Google and others, right?
Yeah.
You speak in one language, it comes out in another. It looks solved.
It looks solved, but it's not. The sources argue that simple translation isn't nearly enough.
Why not?
Because it's about cultural mismatch. You can take a physics problem and translate the words into Hindi perfectly, a word-for-word, grammatically correct translation. But if the problem uses a baseball metaphor, talking about a pitcher throwing a curveball and a batter's slugging percentage,
You deliver that to a kid in a village who has only ever known cricket.
you've lost them completely. It's gibberish. It's not just the language, it's the context, the idioms, the cultural touchstones. It has to be transcreated, not just translated.
And beyond metaphors, there's the issue of dialects.
Yeah.
And something the sources call code switching.
Yes. Code switching is when you mix multiple languages in the same sentence, which is how hundreds of millions of people actually speak.
Like Hinglish in India.
Exactly. A sentence like, Chalo, market shaltahain, we need to buy vegetables. Let's go to the market. It's a mix of Hindi and English. Most of these big, rigorous, safety-tuned AI models, they are trained on textbook language. Pure English, pure Hindi.
The Queen's English.
Right. They hear this messy, fluid, real-world code switching, and they freeze up. They can't parse it. They sound like a stuffy bureaucrat trying to talk to a teenager. The connection is lost.
And even if you solve the language and the infrastructure, then there's the pedagogy, the actual style of teaching. The sources make a really sharp point that AI often optimizes for answers rather than understanding.
This is so critical. It's the danger of what educational theorists call over-scaffolding.
Meaning you help too much.
You make it too easy. If the AI's main goal is to keep the user engaged and happy, and it detects the student is struggling, what's the easiest way to make them happy?
Just give them the answer.
Just give them the answer. The answer is 42. The user feels successful, the session gets a positive rating, but the student has learned absolutely nothing.
They've learned to ask the AI.
They've learned to be dependent. Real learning requires what's called productive struggle. You have to wrestle with a problem, you have to get it wrong a few times. But most AI is optimized for user satisfaction, which usually means get me the result as fast as possible. It's the difference between a great tutor who challenges you and a simple cheat sheet.
And this can even be misaligned with the local education system itself.
That's another great point from the sources. Many of these systems are based on rote memorization for standardized exams. If the AI tutor is trying to teach deep conceptual understanding of physics, but the kid knows they just need to memorize 10 formulas to pass the test that determines their entire future.
They're going to ignore the AI and just ask for the formulas.
Of course. The AI has to be smart enough to navigate that tension between true pedagogy and the on-the-ground reality of the exam system.
Plus, you have the human bottleneck, the teachers.
Right, because teachers aren't just distribution channels for your cool new app. They're the gatekeepers of the classroom, and their fear is completely rational.
It's not lettism.
Not at all. If you, a tech person from a rich country, drop a shiny tablet into a classroom and say, this will teach your students better than you can, what the teacher hears is, this is here to replace you.
Or, this is here to spy on you and report back to the principal if you make a mistake.
Exactly. There's a deep-seated distrust. If you don't win the teacher's trust, if you don't make them a partner, that tablet stays locked in the supply cupboard. We see this happen constantly in development projects. The tech gets delivered, but the culture of the classroom rejects it.
And finally, let's talk about pilot purgatory. To me, this is the saddest one.
It's the graveyard of good intentions. It is a recurring tragedy in the world of nonprofits and ed tech.
So paint the picture for us. How does it happen?
It starts with so much hope.
Yeah.
You get a big grant from, say, a philanthropic foundation. You have a great idea. You design a pilot project for 6 months in a few dozen schools.
You bring in the best people, you give everyone a device, you pay for the internet.
You control all the variables, and
Wow.
it works. The results are amazing. The kids' test scores go up. The teachers love it. Everyone is cheering. You write a glowing report.
And then?
Then the grant money runs out, and you discover the unit economics don't work without the subsidy. The cost per student is, say, $100 a year, but the government can only afford 5.
So the project dies.
It dies. The tablets are taken back. The internet is shut off. The teachers go back to the old way. All that data, all that learning, all that momentum, it's just lost. And a year later, another group comes in with another grant and starts the exact same cycle all over again. We have to escape this endless loop of pilot, success, death.
So how do we escape it? It sounds like an impossible set of problems. But the sources propose a very specific solution, the trifecta solution. 3 components that have to happen together to break this cycle.
Yes, and the key is that they are interdependent. You can't just do one. You need all 3.
Okay, so component 1, conversational AI in 100 languages.
And the key word there is conversational. We have to move beyond text.
Why is voice so critical?
Because there are 750 million illiterate adults in the world, and parentless children who are pre-literate or struggle with reading. A text-based AI, like ChatGPT, does absolutely nothing for them. It's a wall.
But everyone can speak.
Everyone can speak. Voice is the survival-grade interface. It's inclusive by default. It's the most human way to interact. You don't need to know how to use a keyboard or navigate a complex menu. You just talk.
And as we discussed, it needs to speak fluently, not just as a clunky word-for-word translation. It needs to understand the code switching, the dialects.
Correct. It needs to handle interruption. A real conversation isn't turn-based. People talk over each other. It needs to handle background noise, a rooster crowing, a truck going by. It needs to be robust enough for the real world, not a soundproof studio.
So that's the software layer.
Mm.
But it's useless without the pipes. Component 2 is the infrastructure. The Starlink argument, or more broadly, free satellite internet.
Now, this is where it gets into the economics of space, and it's absolutely fascinating. The core of the argument is about sunk costs.
Explain that.
Think about a satellite constellation like Starlink or Amazon's Kuiper. You spent billions of dollars to design, build, and launch thousands of satellites into low Earth orbit. That's the sunk cost. It's already spent.
They're already up there.
They're already up there, orbiting the Earth every 90 minutes. And they are broadcasting a signal continuously. The laws of physics don't let you turn off the signal just because you happen to be flying over a poor country with no paying subscribers. The signal is still hitting the ground.
So if a Starlink satellite flies over a remote village in the Congo or a rural part of the Amazon where there are no paying customers, that bandwidth is just being wasted. It's hitting the dirt and evaporating.
Exactly. The marginal cost of letting someone in that village use that signal is as close to zero as you can get. The expensive part is done. So the proposal from the sources is a freemium model for the planet.
Like Spotify, but for internet access.
Precisely. For the world's 100 poorest countries, you offer a basic survival tier of internet. It wouldn't be fast enough to stream 4K movies, but it would be more than enough for voice, for text, for basic educational applications. A lifeline.
And the source connects this to what they call symbiotic capitalism, looking specifically at Elon Musk's ecosystem as a prime example. This isn't just charity.
No, it's incredibly strategic. Think about the loop. You use Starlink to provide free or ultra-low-cost internet to the next billion people.
You bring them online.
You bring them online. What's the first thing they do? They join a social platform, maybe a platform like X. They start generating content, asking questions, creating data.
And that data is used to train the AI.
It's used to train the AI like Grok. You are getting the most diverse, most valuable training data set in human history. The ecosystem grows. It's not charity, it's customer acquisition at a planetary scale. You are onboarding the next billion users before your competitors even know they exist.
Plus, there's the massive geopolitical angle, soft power.
Huge, absolutely huge. If the West, through companies like SpaceX and Amazon, doesn't connect these regions, someone else will. China is building its own satellite constellation.
So it's a race.
It's a race for influence. It's soft power beamed from low Earth orbit. The internet isn't just cables under the ocean anymore. It's a projection of national and corporate influence.
Okay, so we have the voice AI software, we have the satellite internet, but you still need something in your hand to receive the signal and talk to the AI. That's component 3, the $10 AI device.
This is the hardware breakthrough that ties it all together. And we are not talking about a cheap, stripped-down smartphone with a terrible screen and angry birds.
No.
No, the sources argue for a new class of device entirely. Think about it. Maybe it has no screen at all. Or a very, very basic e-ink display. It's voice first.
So it's more like a walkie-talkie to the AI.
That's a great way to put it. It's rugged, maybe it's waterproof, solar powered. It has a battery that lasts for a week, not a day. It has one job and it does it perfectly to connect you to the tutor.
It's kind of like the one laptop per child idea from years ago, but maybe actually feasible this time.
Exactly. And by removing the screen, or at least the full-color high-res screen, you bypass the dopamine traps.
The distraction.
The distractions. A smartphone is a distraction machine. It's designed to pull you into social media, videos, games. A dedicated voice-based device is a learning machine. It focuses the interaction. And crucially, the source suggests it should have a direct-to-satellite connection.
What's that mean? Why is that important?
It means it doesn't need a local cell phone network. It talks straight to the satellite. This allows you to bypass the often corrupt or inefficient local telecom monopolies. You don't need a SIM card, you don't need a phone number. Your identity is tied to the device. It's a radical simplification of the whole stack.
That is a huge idea. That brings us to the economics of all of this. Section 4. How do you possibly pay for this?
Yeah.
The sources have a fascinating name for the strategy. Their reverse Tesla model.
It's brilliant. It's such an elegant inversion of the standard Silicon Valley playbook.
So walk us through the Tesla model first.
Tesla started with the Roadster, a super expensive, low-volume, high-margin sports car for rich people. They used the profits from that to fund the development of the Model S, which was a bit cheaper and sold more. Then they used those profits to fund the Model 3, the mass-market car. Start high, then go low.
Start niche, go broad.
Exactly. The sources argue that for global education, you have to do the complete opposite. You have to do the reverse Tesla.
You start with the mass market.
You start with the free layer for the masses.
Yeah.
You give away the universal basics, math, science, logic, reading as global public goods.
Because 2 plus 2 is 2 plus 2 everywhere in the world. Physics works the same in Boston and Botswana.
Precisely. You don't need to monetize basic literacy. You use this free layer to build the largest user base in human history, 1 billion kids. You get the data, which, as the source calls it, is the new oil for training better and better AI. You create a global habit.
And then you monetize.
Then you monetize the premium tiers on top. Maybe it's specialized vocational training. Maybe it's exam prep for university entrance exams. Maybe it's corporate training tools for global companies. But the floor, the basic human right to learn, is free, supported by the premium layers.
And the value of that data asset must be astronomical.
Unimaginable. A real-time data set of how 1 billion people learn, what they struggle with, what questions they ask. It would be the most valuable data asset on the planet.
Let's try to ground this in reality, because this still sounds a bit theoretical. But there is actually a company, a major player, trying to do a version of this right now. Section 5. The deep dive case study on Sarvam AI in India.
This is such a compelling example of what the sources are talking about. It's sovereign AI in action.
What does sovereign AI mean?
It means a country building its own foundational AI capabilities, not just relying on models imported from the US. Sarvam's mission is explicitly in India, for India. They looked at the models coming from OpenAI and Google and said, these don't understand our languages, our culture, our context. We need to build our own.
And they've moved incredibly fast. The sources chart their timeline. They had a project called Open Hathi, which was their big multilingual breakthrough.
Right. That was a foundational step. Then they built on that to create Sarvam M, which is a 24 billion parameter model.
Which is pretty powerful.
It is, but the real secret sauce isn't the size of the model. It's how they've fine-tuned it for the linguistic reality of India.
The code switching we talked about earlier.
Exactly. They built their models from the ground up to handle Hinglish and other mixed languages natively. It's not a clumsy add-on. It's part of the core architecture. And then there's the voice component. They built a system called Bulbul.
What's special about that?
It's a natural voice AI that captures emotion, intonation, and regional dialects. It doesn't sound like a generic, robotic text-to-speech engine. It sounds like a person from your region of India. That creates an immediate sense of trust and familiarity.
One thing I noticed in the technical notes in the source material was FP8 quantization. Can we unpack that? Why does something so technical matter for a kid in a village?
It matters immensely because it's all about cost and efficiency.
Right.
So an AI model is basically a huge collection of numbers or parameters. Quantization is a process of simplifying those numbers, kind of like reducing the color palette of a digital image or lowering the resolution of a video from 4K to 1080p.
You make the file size smaller so it's easier to handle.
Exactly. You make the model smaller and simpler without losing too much of its intelligence. FP8 is a very aggressive form of this. It allows them to run these powerful models on much cheaper, less power-hungry computer chips.
Which means the cost of answering a single student's question.
It plummets. It drops drastically. If you're running your AI on expensive, top-of-the-line NVIDIA GPUs in a US data center, every question costs a fraction of a cent. That doesn't sound like much, but when you're serving a billion people asking billions of questions,
It becomes an impossible number.
an impossible number. FP8 and other efficiency tricks mean you can serve those billion people at a cost that is actually sustainable. It's a critical piece of the economic puzzle.
And they are taking this a step further by building sovereign infrastructure. The sources mention the sovereign AI park being built in Tamil Nadu.
This is a massive strategic move. They're not just designing the software, they're building the physical data centers to run it on. They're building domestic compute capacity.
Why is that so important?
Resilience. They don't want to be dependent on Amazon Web Services or Microsoft Azure servers located in the US or Europe. If geopolitical winds change, if sanctions are imposed, if a cable gets cut, they want their country's education system to keep running. It's about national security and digital independence.
And yet, even with this India-first approach, they have global ambition.
They do. And their argument is incredibly compelling. They say, if we can solve this for India, with its hundreds of languages, its massive scale, its infrastructure gaps, we can export that model to the rest of the global south.
The challenges are transferable.
The challenges in India mirror the challenges in Nigeria, in Brazil, in Indonesia. Dozens of languages, intermittent power, the need for low-cost solutions. If you can build a system that works for 100 languages and spotty 2G in India, you have a solution for most of the world. It's a powerful counterweight to the Silicon Valley-centric view of AI.
This shifts us to section 6, which is where the design philosophy behind all this gets really interesting. The sources call it the boring revolution.
Hey, I love this part so much. Because it starts by looking at why so much of the futuristic tech we've been promised in the past has failed so spectacularly.
And we have to start with the Zuckerberg helmet, the VR headset.
The VR headset, the source we're pulling from calls it a love letter to vertigo, which is just perfect. It's a piece of technology that fundamentally ignored human biology.
Oh.
It strapped a heavy screen to your face, creating a mismatch between what your eyes saw and what your inner ear felt, which is the textbook definition of what causes motion sickness. It made people nauseous. It gave them neck strain. It isolated them from the real world. It tried to replace the infinite resolution of reality with a low-resolution cartoon, and people's bodies just rejected it.
And then there's the other great anecdote from the sources, Sergey Brin on the New York City subway with Google Glass.
The ultimate stress test for any new technology. So you have Sergey Brin, one of the most brilliant minds of our time, wearing this futuristic piece of eyewear onto a crowded subway car.
Right.
He's looking up at notifications only he can see. He's talking to himself, issuing voice commands, his eyes twitching to interact with the interface. And the people around him, they don't think, wow, there's a visionary from the future.
No, they think he's unwell.
They think, this poor guy is having a breakdown. One of the sources notes that someone literally tried to hand him spare change because they thought he was destitute and mentally ill.
And the lesson from both of these is what?
Technology must adapt to biology and society, not the other way around.
Yeah.
You can't just brute force a new interface onto people if it violates basic social norms or makes them physically sick.
Which is why the sources argue that education AI must be boring.
Exactly. It shouldn't be flashy. It shouldn't be a headset that makes you dizzy. It shouldn't be weird glasses that make you look crazy. It needs to be the Toyota Corolla of AI.
Not the Ferrari.
Not the Ferrari. It doesn't have to be exciting. It has to be reliable. It has to be invisible. It needs to be offline first. It just needs to work every single time without getting in the way. Boring is a feature, not a bug.
The sources also talk about this idea of curriculum universalism.
This is another key to making the economics work. Don't reinvent math. Physics is physics. The Pythagorean theorem is the same everywhere.
So you don't need to build a custom curriculum for every single village on Earth.
Please don't. That's a recipe for failure. The core concepts are universal. The task of the AI is not to invent new science, but to translate and contextualize the universal basics. It's about building a custom interface for every village, not a custom curriculum.
Which brings us to the final major section, and maybe the most important one, the human element and culture, section 7.
This is where we have to confront our own biases. One of the sources has this beautiful line: "No one is dumb, just different."
What does that mean in the context of AI?
It means that AI has the unique ability to adapt to different learning styles in a way that a single human teacher with 50 kids in a classroom simply cannot. Some kids are visual learners, some are auditory, some learn by doing.
A teacher can't possibly cater to all of them at once.
They can, but an AI can. It can notice that a student is struggling with a text-based explanation and offer to show them a video or an interactive simulation instead. It can personalize the learning path for every single child.
And it's not just about learning styles in the Global South. The source is quick to mention the education deserts right here in the U.S.
Absolutely. Functional illiteracy is a massive problem in many developed nations. There are communities where the schools are failing, where opportunity is scarce. This isn't a poor country problem, it's a global problem of mismatched resources and opportunities.
But adapting to culture is so delicate. The sources talk about treating languages like endangered species, linguistic biodiversity.
This is a beautiful idea. When a language dies, an entire way of thinking about the world, a whole body of knowledge, dies with it. AI could be a powerful preservation tool. It can learn these rare languages, document them, and even teach them to new generations.
But that requires collecting a lot of voice data, which raises huge privacy issues.
It does. And that's why the sources talk about the ethical voice data idea. You need to do this carefully. Maybe you use on-device learning, where the AI learns on the user's device without sending raw voice recordings to a central server. You have to be transparent and get consent.
You have to respect the parents.
The parents are the ultimate gatekeepers. Always.
If they don't trust it, it's over.
It's over. If the AI says something that insults their values or their religion or their cultural traditions, that device gets locked in a drawer and never comes out again. The AI has to be culturally polite. It has to understand hierarchy. In some cultures, you don't interrupt or challenge the teacher. In others, debate is encouraged. The AI has to be smart enough to navigate that social landscape. If it gets that wrong, it fails.
So we've unpacked the huge problem, the painful reality on the ground, the three-part trifecta solution, the reverse Tesla economics, and the critical human and cultural element.
It's a lot.
What does this all mean? Let's head to the outro and what the sources call the final wager.
The wager is this. If we can teach the world's poorest and most disconnected children using AI, if we can successfully navigate the infrastructure, the culture, the cost, all these pain points we've discussed, then we prove, unequivocally, that AI can be a force for good.
It's the ultimate proof of concept for safe, beneficial AI.
It is. We prove it can be aligned with human values because we've used it to deliver on one of the most fundamental human values, the right to learn.
It's the peace treaty that's drafted in a classroom before the great war of superintelligence ever has a chance to begin.
And just think about the potential upside for a moment. It's almost too big to comprehend. The distribution of talent in the world is uniform. Genius is born everywhere, in every village, on every continent.
But the distribution of opportunity is not even close.
Not even close. What happens to the next Einstein or the next Marie Curie who was born today in a village with no school, no books, no teachers?
The potential is lost. It just evaporates. A mind that could have cured a disease or solved climate change ends up doing manual labor because that was their only option.
Exactly. But what if they had that $10 device?
What if they had a voice in their ear they could patiently answer every single question they ever had, from why is the sky blue to the principles of quantum mechanics?
We aren't just solving an education crisis. We are unlocking human capital on a scale that humanity has never, ever seen before. We are literally adding brain power to the human species.
That is the provocative thought to leave on. We're not just fixing a deficit. We are creating a new kind of abundance, an abundance of intelligence.
And the sources are clear on this final point. We can't wait for governments or the UN to figure this out. The builders, the tech companies, the satellite providers, the AI labs, they have the technology and the resources to execute this now.
It's a heavy responsibility, but an absolutely incredible opportunity.
The biggest one there is.
All right, that's our deep dive on AI in global education. It's dense, it's complex, but it might just be the most important thing happening in technology right now. Thanks for joining us.
Thank you.